Okay guys, let's talk about vertical shifts for sine and cosine graphs. So my very first graph here, I added a little something here. It's this 2. Guess what? This is my vertical shift. And since it is a positive 2, it's going to move my graph up 2 units. We've already seen the other 2 numbers and what they do, but let's just review. This guy right here, I take its absolute value, I would get positive 3. That guy would be called my amplitude. And then this guy right here is my b value, so I would do 2 pi divided by b, which gives me pi halves as a period. So a little bit, I'm going to throw something out here. When you're talking about the period, what you're talking about is this graph is going to be from 0, then all the information you see on the x-axis is from 0 to pi over 2, and that would be considered one period for this graph. I'm going to introduce this kind of look here because you'll see it in the next lesson how it affects our shifting. But what am I getting at? If I'm going to sketch this graph, I'm going to come down here and I'm going to draw a coordinate system, but I'm going to extend it on the right quite a bit. You'll see why in a few seconds here. But I still need to know my increments. So I take whatever the period is. Remember, whatever this period value is, I do pi over 2 here times 1/4. That means the dashes on my x-axis, I'm going to be counting by eighths. So 1/8, 2/8, 3/8, 4/8. So once again, my graph will start at 0. And then, like I'm saying here, that would be 1/8. 2/8, but I don't call it 2/8. I reduce. I call it 1/4 or pi fourths. Then 3/8, 3 pi eighths, and then I don't say 4 pi eighths. 4 pi eighths would reduce to pi over 2. Now, what I just marked out there sideways is one entire period. It goes from 0 to pi over 2. That would be one period of movement. But I haven't applied my vertical shift yet. So here's what I want you guys to get used to doing here. You're going to go up 1, 2 units. Now this right here, I'm just going to use a separate color so you see it. This guy right here, I'm going to draw it in. This dude, I'm going to call my center line. My center line. It's 2 units up. That is my vertical shift. Now, be careful because I also have an amplitude adjustment. So I'm going to have to extend a little bit here on my y-axis to make this work. I'm going to go up 1, 2, 3 units from the center line. My amplitude is 3 units up from the center. So the center line is at 2. That would put this highest point at 5. Now, where is my lowest point going to be on this graph? It's going to be 1, 2, 3 units down. So when I sketch this graph, I'm just going to draw one period of this function, and then I'll come back and get the second period. I start on the line, but on the line is up here. It's not down low. On the line. You know what? I want to make this stand out, so I'm going to use a different color. I'm going to use blue. So I'm on the line, then I'm not flipped, so I go above the line. Then I come back to the line. Then I go below the line. Then I come back to the line. And if I sketch this graph, oop, I almost got it there. If I sketch this graph, that would be my sine graph being amplified by 3, having my period compressed because of the 4. Also, I'm shifted up 2 to begin with. Now, what I just sketched for you is indeed one period of this function. The section we're going to be doing in the book, they have all of the graphs graphed over 2 periods. So here's the thing. I just want you to know that this is totally a valid move. If you really want to, you just drew 1 period. It goes through the whole cycle. You could just keep extending it down the line. Remember, this graph is infinite in both directions. It is infinite in both directions. But if all they want is 2 periods of a function, well, I could just say, okay, I left off here at pi over 2. Remember, pi over 2 could be 4 pi eighths. So this next mark would be 5 pi eighth. Then 6th pi eighth, but I would reduce that. Then 7 pi eighths. Then 8 pi eighths, but I would reduce that. Right? So if you want to, you don't have to do half of your graph on the right side of x and half of your graph on the left side of x. No, you could have just come over here and said, I'm going to extend everything on this side of my graph. And I could, whoop, God, that's kind of crummy. The first part was really good. That part's a little bit sloppy. But there's 2 periods. If I wanted to, I could say there's 1 more period of my graph. Boom, I'm done. But just so you know, the book is going to do it backwards. They are. They're going to end up coming over here and saying negative pi half, or sorry, pi eighths, then negative pi fourths, negative 3 pi eighths, negative pi over 2. And while I'm doing this, I want to caution you, when you shift a graph vertically, don't accidentally go, oh, I'll just put my dot right here. Guess what? That dot does not land on the x-axis for this example. It doesn't. Undo that. Remember, it's down 3 from the center line. Then it goes back to the line. Then it goes above the line. Then it goes back to the line. So when you have a center line adjustment or a vertical shift, oh God, that was horrible. When you have, I'm just talking about that. That's kind of bad, but I'm not going to redraw it. Anyway, when you have a center line adjustment, be cautious. Don't put dots in the wrong spots. Remember, all of these numbers have a job to do, and you got to let them do their job. But let me point this out, a couple things I look for when I'm grading it. When I'm grading it, make sure you tell me what your center line is. Don't assume I'm going to know it. Also, label the highs, the lows, and the middle on the on the y-axis. If you make me guess, I will guess incorrectly and I'll mark it incorrect. Then, for sure, if it says graph for 2 periods, I don't care if you do 1 period on this side and 1 on this side, I don't care. But this graph right here, I have 3 periods graphed. If the instructions say 2 periods, don't give me 3. Don't give me 1. Don't give me 1.5. If it says 2, give me only 2. But let's look at a couple more examples of this type of graphing. And remember, the only thing we're really adding here is what's called a vertical shift, which we've done for every graph up to this point. We're not doing anything new. This is vertical shift. We'll add the sideways shift on the next lesson, but not this lesson. So let's do another. Let's take a look at this one, because this one is a cosine graph. Let me ask you, which one of these numbers here, because I have 3 numbers, -2, 1/2, 1/3, which one of these numbers will affect my period? This guy is going to affect my period. It's going to adjust the period. Its name is B. That's called the B value. Which one of these numbers is my amplitude? my amplitude would be 1/2. And then, of course, this guy is my vertical shift, but this time it's going to cause my graph to go down 2 units. Now, when it comes to amplitude being a fraction, you don't have to make everything, rearrange all your scale and stuff for me. I will let you just mark it off halfway between units. That's fine. So, for example, on this particular problem, to save myself some room, I am going to graph everything on one side. I am going to put my y-axis right here. But I know that my graph has a center line at -2. So once again, just to keep it like I did last time, I'm going to put my center line at -2. And I am going to denote that for you. Center line. That's this guy. And I'm going to mark it off. There's -2. But if I'm counting by halves here, that would mean right here at -1.5, that would be the height. And down here at -2.5, that would be the low for my graph. So this graph is going to be compressed or smushed down because the amplitude is only 1/2. But like I said, you can break up your number line how you want for this graph to appear. But I am going to this time mark all my increments up here. I'm just going to mark them up here for you. So here's 0. So let's go get those increments. First we need to know the period. So we do 2 pi divided by 1/3, which is the same thing as 2 pi times the reciprocal of that. So we get 6 pi for a period. My period. So this graph starts at 0 and goes to 6 pi. But how big are my counting pieces? 6 pi times 1/4, going to cross cancel. I'm going to be counting by 3 pi halves for my increments. Oh my gosh, increments. Okay, you know what I mean. That's horrible. Here we go. I'm going to mark this one off here. I'm going to say that's 3 pi halves. Then this would be 6 pi halves. This would be 9 pi halves. This would be 12 pi halves. Now take a look at that just for a second. I know I'm supposed to do some reducing. But what I'm trying to point out is sometimes it's easier just to mark it all off and then go back through and reduce your answers. Because I can always come back and say, okay, the next guy would be what? 15 pi halves. Then I would have 18 pi halves. And then I would have, what, 21 pi halves. I got one more in me, it's 24 pi halves. Okay, just go back and take a good look at it. I can't reduce 3 pi halves, but I can surely reduce 6 pi halves. I could have said that thing is the same as 3 pi. 9 pi halves won't reduce, but 12 pi halves, that's 6 pi. And look, I didn't need to write the pi. I already had the pi. So 6 pi, and guess what? That was my period. So that's one period. Then 15 pi halves can't reduce, but 18 pi halves, that can reduce. I would call it 9 pi. 21 pi halves won't reduce, but 24 pi halves, I'm going to make that thing 12 pi. And it's as simple as that. I just count, and then I go back and clean it up if I have to. I'm going to do my graph in blue like I did last time. So this is a cosine graph, a non-flipped cosine graph. So it starts above the line. Then it goes on the line. Then it goes below the line, back on the line, above the line, because that is what cosine does. There is one period of that graph. But I continue the pattern. So I go back to the line, I go below the line, I go back to the line, I go above the line. And that would be the second period of that graph. And it's okay to graph one period right next to the other period if it makes it easier on your brain. It doesn't matter to me. That's 2 periods back to back. That is 2 periods of this graph. They just both happen to be on the positive side of the x-axis. And that's okay. Let's do one more just for good practice. One more practice problem. And this time, let's see what we got. Okay. I got a vertical shift, and then I got a flip, then I got amplified, then I got a period adjustment. Now here's the beauty of it. It doesn't matter where you start the process. I'm going to start by telling you I'm going to graph half of this on the one side of the graph. Come on. And I'm going to graph the other half on the other half. That's what I'm going to do. So I'm going to just have it right down the center. I'm going to mark my center line to start with. I'm going to go up 2 units and say, you know what, that's going to be my center line. I'm going to keep my pattern, use my red pen. And I'm going to say, you are my center line. And I'm going to mark it. I'm going to say that's at 2. But wait a minute, this thing is going to go up 3 units from there. So I'm going to go as high as 5, it looks like. I'm going to go 1, 2, 3. I'm going to go as low as -1, it looks like. And I'm going to mark off my increments. But what are my increments for this graph? Well, 2 pi divided by 2. My period goes from 0 to pi. Pi times 1/4 means I'm going to count by quarters. That's my increments. I'm going to abbreviate. So I start here at 0, and then I'm going to go pi fourths. Then I'm going to go 2 pi fourths. 2 pi fourths, let's reduce. 3 pi fourths. 4 pi fourths, let's call it pi. I'm going to go backwards. I'm going to go back and do it on this side. I can do that if I want, as long, whoop, negative. Now let's graph it. You know what? Let's get a little Christmassy colors here. I'm going to start on the line, right? Because it's sine. Sine starts on the line, but usually sine goes up to the right, but I'm going to go down to the right. So I go on the line, below the line, back on the line, above the line, back on the line. It's got a cool beat to it. Es un poquito fresco. Sí, claro. And then we got 1 period of that function. Que bueno. Let's continue the pattern on the other side. So if I was to continue this pattern on the other side, I would go above the line. I would go back on the line. I would go below the line, back on the line. And I would continue the smooth, curved pattern. And I would say that is a flipped, vertically shifted, amplified, compressed version of a normal sine graph. That's what I would say. Now, I want to make sure that you guys check everything on this one. I was disappointed in the book how they did not mark every single increment and every single thing. I want you guys to know you're supposed to mark everything correctly. So let's look at this. I did this for you. I went, here's the problems from page 157. And it says here, graph each function over a 2-period interval. But nobody said anything about the interval being half positive, half negative. So you'll see in my answer key, oh, by the way, pause it, take a picture of it. You'll see in my answer key, look, I did the very first one, I did 2 in a row. I marked my center line, right? And I went down, center line. And then I went 2 periods back to back. All right? But in the book, they did theirs half left, half right. So I did the rest of them like that. But I marked little pieces of information here along the way. Since we're talking about a vertical shift, it's a brand new concept. So take a picture of it. Here we go. Number 47. See number 47? Look at those increments. Pi over 10. They're counting by tenths. And look, I marked my center line for you at -1. Trying to make it easier for you to see what's going on. All right, and then look, I snuck that in. Whoop, stop it. I snuck that in. That says 1/3, by the way. That says 1/3. This one says 1 2/3 because they wanted me to move up and then mark things off. My center line at 1. So anyway, check your answers as you go through. That's number 49. It got chopped off. I can see there. That's 49. There's 50. There's 51. Okay? So when you do these practice problems, there's the 8 answers down below for you to use. And check them, make sure you're getting them right. Now, the next lesson, we put every skill together. And then everything kind of starts falling into place. So our first lesson, we just did sine with amplitude and period. Now we're doing it with vertical shifts included. Guess what? We're doing side-to-side shifting next. That's our next big move. But that's going to be our next lesson. So, catch you guys later. Bye-bye.